Welcome to part 2 of this tutorial where we are looking at how to display your character in a Canvas UI, which could be an inventory. Kind of think Rust if you've ever played Rust. We left off in part 1 with raycasting. We also figured out how to rotate the character, which we have defined in our scripts down here. That's all the logic so far. So what I want to look at now is actually clicking, getting triggers, trigger events, and then we'll finalize everything hopefully in this tutorial, this second part. So what we should do, go back into our script and update. We'll just put the rotate pivot in here. Rotate pivot. Let's define the pivot. So this will just be a private transform pivot. And in start, pivot equals this. And just set pivot here. Oh no. Yeah, do that. Pass in pivot here. So we only want this to rotate if we're clicking and dragging on the display on that render texture. So at the very bottom, let's create some Boolean variables. So this will be private. Private Boolean is rotating. And so we can do if is rotating, it will rotate. Now how do we determine if it is rotating? We will do that by using event triggers in the engine. And the way we'll access this private variable is through an accessor. So create a public Boolean is rotating and use brackets like this. This does not require parentheses like a method does. Accessors require a getter or a setter, get set, and then there's, I think it's just get and set. Yeah, so we're only going to set because we don't need to get it from any other script. We only want to reference this, and we want other scripts like this event trigger we're going to add to call upon this and set is rotating to either true or false. So we can modify is rotating from inside the set by setting it equal to value, which will be whatever we want it to be. The way that this works, if you're unfamiliar, is you can call on is rotating such as this, add an equal to it, and then hit true if you want. And this, when it sees this, it calls upon this right here and sets is rotating equal to true, which is the value. If it had a getter, say get, you would return is rotating. And then you could call upon is rotating. So by doing it, say an if statement, if is rotating, then it will check through this right here what is rotating is and return either true or false. But we don't want to use a getter. We just want to use a setter. And so to determine if we're rotating, let's go back to Unity, go to display, add a component, event trigger. Now add a new event type, pointer enter, and then add pointer exit. On pointer enter, this is just if the pointer goes over the display, and then X is when it exits. And so that way we can call upon methods and accessors when we do that. Drag canvas as the object into it, because that is where our script is. Go to display, is rotating, display is rotating, and hit true here for this and false for this. And save that. And I'll go back to canvas and change it to debug so we can see the variables that are being accessed. So this is rotating right here. Click on this. Watch it. If you put the mouse over it, it becomes true. If you put the mouse off, it becomes false. So it rotates only when it's over now. So that works nicely at the moment. But we want to make it so that when you click and hold. So on, enter, and exit, we can remove these. And we're actually going to do on pointer, begin drag, and end drag. Just repeat. I didn't mean to do on pointer, enter, and exit. Okay. If you click and drag, it now rotates. That's nice. So also we want to go over here and add new event type and on pointer click. And so that way when we click, it will actually click the raycast. I want to only be casting when the mouse is over. So we'll add back on pointer enter and on pointer exit. And we'll create some new accessors so that way we can access via the trigger again. So create another private bool mouse hovering. This will be if the mouse is over the display or not. So set, no, sorry, this is the method. We need the accessor. Public pub bar, public boolean mouse hovering, set mouse hovering equal to value, and put your line end character there. And then I'm going to collapse these for the sake of space. Let's do an on-click method. This needs to be public void on-click. So this is when you actually click, this will be called. And what we want to do then is an update, first of all, cast ray. No, I did not make one. So create a private raycast hit. This instance variable we will be setting right here, hit equals cast ray, because we're returning this cast ray right here, this raycast hit variable right here. And then we can do here, we're going to check if rotating. We don't want to click if it's rotating. If is rotating, not is rotating. Hit dot collider dot game object, yeah. And to just test if it works, we'll actually print the game object. And can you just, yeah, do name, don't do game object. And we'll also test if the hit.collider is null, because we don't want it to be null. That will throw an error. So does not equal null. So we define hit right here with the cast ray. And we'll actually only cast the ray if the mouse is hovering. If mouse hovering is true, cast the ray. If it's rotating, it rotates. Then on click, if it's not rotating and the hit.collider is not null, it will print the name. Did I save it? No, save. And right here, on pointer enter, display, mouse hovering is true, display, mouse hovering is false, on click, display, on click. That should work properly. I'm going to save the scene. So we can see that we're raycasting right now. Go back to canvas and set this to debug so you can see it. Mouse hovering, watch it. It's true. So we are casting. You can see how the marker right here stops. It's because we're not casting. Is rotating, click and hold, rotates. And so let's test the click. If you click, if you look down here, it says the name of it. Body, cube 3, I didn't actually name it in leg. So what if you go to click and then you start dragging and then you release? It does nothing, it prints nothing. And if you click the sky, prints nothing as well. So that works the way we intend it to. Very nice. So now you can do whatever you want with this. Printing the name is kind of lame. Let's set it to a random shade of green. So you can do hit dot collider dot get component mesh render dot color, no, material dot color equals new color. And I'm just going to copy this in because I don't want to paste it. So no, that would have been bad. Don't delete your entire script. Be very careful. There we go. Sweet, it's green. But the ground, that changes to random shades of green. We want to make it so that now we can't see the ground at all. And also we don't want to see the sky either. We actually just want either the background to be black or transparent. So the way we're going to do this is through layering. Go click on stick person, layer, add a layer. It's debugging's on, turn off debugging. This is going to be called, I'm just going to call it display. Everything that we want this camera to see needs to be in the layer display. So set culling mask to nothing and then display. We can't see anything but the sky right now. So change skybox to solid color. And so since alpha is 0, you can't see it at all. Bring it up for right now and set it to black. Go to stick person, set his layer to display. Yes, change children. Now you can see him. You can't see the sky at all. If you want it to be transparent, you can just turn the alpha back down to 0 and you see only the character, which is very nice. I'm also going to set marker to display so we can see it when we're testing the game out. Yeah. Works very nicely. Now, we want to set it so in the script, we want to be able to just parent this to your anything you want. It doesn't have to be the character. It can be a cube of butter for all I care. Brick of butter, just a brick. So in the script, we're going to pull this up. We're going to create a target variable. Private transform target. And that needs to have an underscore. Per coding style needs to be consistent. And we're going to create another accessor. So I like to keep the accessors separate from all the variables. There we go. This is going to be public transform target set target equals value, and this is going to contain some more implementation to it. You can execute more code. We want to set the position of the display anchor to the target. So display anchor dot transform, no, just position. Actually set parent to the target. And then you can set its local position. Dot local position equal to vector3.0, and that just sets it centered to your target. We also want to be checking if the target is null, because if it was null, then none of this would work and we get errors. So if null, if target equals null. And let's actually just create a boolean because we're going to use this later. So bool is null equals that. And you can check if is null. Okay, so if is null, set the parent. Actually, you can just move this up like here and just change this to, target. So that way if it's null, it will just set the parent back to be the global parent of nothingness. And local position, we can put this up here as well. It doesn't need to be in here. If is null, what are we doing in here? Changing the layers. This is where we'll change the layers, because if it is null, then you can't change the layers because there's no layers to change. So we'll add this later, change layers. And we're also going to set it active. So display anchor. No, let's do the pivot. Pivot dot set game object dot set active is equal to is null. We're actually going to set it to is the opposite of is null, so that way if it is null, it's false and it's set unset active. If it is not null, it is set true, so you can see it. And so we need why getting an error. Oh. Right, okay, let's create the method to change the layers. It's going to be recursive method. If you don't know what recursive is, it's just calling the same function within itself. Pretty self-explanatory. So create a private, actually this can be a public static void, because that way the code can be reused. Change layers. And get a transform target, and then int layer. And then so target dot game object dot layer is equal to layer. We change the layer of the target, and then we're going to change all of the children that are parented to the target. Change all of those layers. So for each transform child in the target, call change layer, and then just pass in the child and the layer. So what this does then is it just, for each child on the target, it will call the same function on that child, and then all that children's children, and so on and so forth until you've gotten it all done. If you don't understand recursive very well, it'd be good to go watch a tutorial on it. I'm not going to explain it right now, but this will work, and I can show you. So go here and change layers, target, and we're actually going to let's make some constants while we're at it. I'll explain constants at the moment. So notice how we're using 360 everywhere. These are defaults, so these are fine. But down here, we have these magic 360 numbers. You might not understand what those mean if you come back and look at the code later. So it's good to have constants. So private const. We're going to call it actually float and call it turn. A turn is a geometric turn. Sorry. The word turn is a geometric term for 360 degrees. And actually, per coding style, it needs to be all capitals. And create another private constant. This is for the layers. Float layer default. Layer default equal to 0. And it's actually going to be an int. And this is going to be layer display. And I set it to layer 8. You can get that number by clicking display, add layer, and it says 8 right here. So that's why that's 8. Oops. Layer display changes it to that. And also, so if there's a target that we're changing from, so the old target, this is the new target. The old target, we want to change its layer back to the default layer, so that way we can't see it if we don't see it in the display. So target, let's do if target does not equal null. Change layers, target layer default. Yeah, so that will change that back to the default, to the display. That should work just fine. And also, while we're at it, let's replace everything that is a 360 with turn. So that way you can change this later, and it changes all those for us. But I don't want to change it later. It's nice to have constants. It's good coding style. So let's go into start. And target is equal to game object dot find stick person. This will find stick person for us. Stick person dot transform. And so this will work. This should clear. Yes. Okay. No errors. Good. Go to stick person and change his layer back to default. Yes. And so we'll move this to like somewhere out here. And so you should see when we start it, the position will, this will be parented to stick person. Also the position will become 0, 0 by 0. Stick person's layer will change as well. Let's see. Oh, it didn't change. And what parented? What happened? What did I do wrong? Layer display if is not null. Sorry. There you go. Try it again. And yeah, see, it worked, and all of its children changed because you can see all the legs and everything, and they're all display as well. So that works nicely. It parents it so that way when stick person does move, it will follow. Follows it. And also, so the reason we're creating this anchor right here, rather than having just the pivot be parented to the target, this is here to help with scaling issues. So if this were to parent to, say, the body, notice that the scale changes. The rotation would rotate incorrectly if this was the pivot. So the pivot, therefore, is under display camera, and it fixes all the rotational issues you would have, which comes with scaling, and it should scale normally. Yes, it does. So that's nice. And so that changes the target via code. And then, so that works fine. Go here. So I think I can do a part 3 in which we look at the lighting. So if you don't care about lighting, you don't need to watch part 3, but this works nicely. You can click, do things. Oh, shoot. Okay. There is another issue that I need to look at. Clicking on things that shouldn't be clicked on. So if you just go, we need a private layer mask. And actually this will be, let's serialize the value. Serialize field and move it up. Oh, if you hear any voices in the background, I apologize for the extra sound. Call this layer and go down to our cast ray method. And this can take another parameter, and it will be the layer mask. So actually, we want to pass in layer right here. So int layer, and then we'll pass in the instance variable here, so it becomes local layer. Actually, it needs to be the constant that we defined. Oops. So no, that's not right. Sorry, this needs to be layer mask, not the integer. So then we can do that. So we're passing in this layer mask, not an integer, and this will be defined here. And so anything that is only of layer display shall be able to be clicked on in raycast 2. Notice that you can no longer click on the ground. You can't click on stick person either, because we did not set the layer mask here to display. Now it works, and it does not work on the ground anymore. Also, try scaling it. Notice that the scale still works. Everything works properly, works fine. I don't really see any bugs with it that I don't want to see. So I think everything's good right now. And yeah, that's it for part 2. Part 3 will involve, if your character goes into a dark area, we'll fix up the lighting. So that way the display has its own separate lighting that the main camera cannot see. And it will look good even in the dark. So yeah, thank you for watching. And please come back for the third part.